Hi, I'm Nick, and in this video, I'm going to show you how to create tokens on Solana using the new JavaScript clients. Specifically, we're going to be using Gill in this example. You can do a lot of these similar things with Web3.js version 2 or Solana Kit, but Gill makes it a whole hell of a lot easier. So let's go ahead and dive into some code here. So much like the previous video, if you haven't already seen it, how to get started with the new JavaScript clients, we have Gill installed. We've updated from the last version. This is 0.4.0. The last video was 0.2. And we're just gonna dive in and start writing some code. So the first thing you're gonna need when you're building these transactions and sending them to the blockchain is you need a connection to the blockchain. So let's go ahead and create that. I'm gonna create a Solana connection. So create Solana client. I'm gonna import this directly from Gill, and I'm gonna pass in my URL or moniker. And specifically, I'm going to be using DevNet for this. You can use any of the other clusters. The particular address that I'm going to be using for this this demo here is this NIC6Z address. And to show that it also has a balance, I'm going to get the balance on DevNet. And we have some DevNet sol available, so we can do all things that we would want to do with DevNet. So we're going to go ahead and grab our RPC and eventually the send and confirm transaction function, so we can actually, send and confirm the transaction later when we build it. But now that we have a connection to the blockchain, we can start building our actual transaction to create our token. This is going to come in a couple of different steps. The first thing we're going to need is we're going to need a signer. Now, since we're doing this all with the sort of CLI scripts and everything, we're just going to load a CLI our key pair signer from my local file system. I'm actually going to load this NIC6Z address directly from my file system. And in order to do that, Gill has a helper function to load files for our load key pair signers from the file system. So I'm going to load a signer. This is key pair signer from file. And by default, this is going to give us the exact same address and key pair that I've sort of displayed in the console there. So I'm going to go ahead and log this out too, just to show it. And signer.address. Just to show that this is the same exact address, we're going to use esrun to run these scripts, and I'm going to pass it in this file name, and you can see here we have the exact same NIC6Z address. So now that we have a signer, let's go ahead and start building our transaction. So I'm going to create a new transaction object. I'm going to call it TX for short. Super common convention for creating transactions, and also same with IX for instructions. But we're going to call the create transaction function, and I'm struggling with typing today. But we're going to call create transaction that's again imported from Gill, and we can start use our IntelliSense here. We can see all of the values we can pass in, and we're just going to start passing in all of these required attributes. We'll start with the fee payer. Pretty typical thing when building transactions is they all need some sort of signer, whether it's a user's wallet from their Phantom, Backpack, Soulflare, or whatever, or if you have a key pair loaded from your local file system or from your backend server, you can load that in as well. Next up is going to be the version. I'm going to use a legacy version, so we're not using address lookup tables here, so we don't need a version 1 or a version 0 rather. The next thing is instructions. This is going to be an array, and this is actually how we're going to tell the blockchain all the information it needs in order to actually create our token. We're just gonna leave this blank as an empty array here. And then the next thing is we're gonna pass in this latest block hash. We don't actually have this latest block hash yet, but now that we have a connection to our RPC, we can get our latest block hash. So we're gonna call rpc.get latest block hash. And typing is apparently not my strong suit today, so I apologize there, but we're going to grab this latest block hash. We're going to destructure this and rename it. There we go. So now we have our latest block hash, and effectively we have a transaction that's sort of ready to be signed and sent to the blockchain, but it doesn't do anything yet. In fact, if you tried to send this, it would literally fail because there's no instructions. Every transaction is required to have some instructions in it. So let's go ahead and actually build our instructions that we need to actually create a token. So there's a couple of ways that you can create tokens on Solana. There's different programs you can use, and then different other programs you can use for metadata. So let's talk about that real quick. There's two primary token programs that exist. There's the SPL token program, sort of the original one. It's the legacy token program. And then there's the token extension program. This is the newer iteration, also from the engineers at Anza and from Solana Labs. And basically, these two programs, they're very identical in a lot of ways, but the token extension program has these idea of extensions that are built in natively within the program. So it sort of offers these different ways you can have customized logic without implementing that many new features yourself or creating a completely new token program. It sort of ships them easily and accessibly. For this first demo, I'm actually going to go through creating using the legacy token program, and sort of the two main caveats here that you have to think about is, one, the legacy token program does not support metadata by default internally within its own program. So we have to use a different program for metadata. And in this case, we're going to use Metaplex's token metadata program. Gill ships with the functionality inside of it to use Metaplex's token metadata program, so we can go ahead and use that. The other option is if we wanted to use the token extension program that has metadata functionality built into it in using the form of metadata pointers and the metadata extension, so we can actually have just a single program that controls both the metadata and the mint itself. But let's go ahead and use the original token program, since that's what most people are most used to. So in order to actually create our mint, we need a couple of instructions, and we can put all of these in the exact same transaction, which is really great. So the first thing we need to do is we need to sort of allocate our mint on chain. So we need to generate a new random address. So we'll call this mint, and we're gonna generate a key pair signer. And so now that we have this key pair signer, we can log this out if we want to. And every time we run this, we'll just get a different address. We can run it once. We have a 13J, we have a EHB, whatever. It's completely randomly generated. And once we have this, we can actually tell the blockchain to allocate this account on chain. And the way we do that is with a system program instruction called get. It's called the create account instruction, but we can call it using get create account instruction, which is exported from gill. And we can pass in all the information we need here. You can see we have the LAMP ports, new accounts, the payer, program address, and the space. So the LAMP ports is the total amount of space that we actually need to allocate this account on chain. And because this account is our token mint, we need to know how much space our token mint actually needs on chain. So there's a function for that. So we can calculate the total space that we need using a function that's exported from the SPL token package, or I guess the Solana program token package, which is also exported inside of gill. So it's called get mint size. And this will give us the total mint size that we need for our transaction, this actual account that we're gonna send for the mint itself. So now that we have the total space, in fact, we'll just put that in there because we need the space. And this will basically just calculate how much actual space we need to actually allocate on chain. Now that we have the amount of space, we can get the minimum balance for rent exemption, and we need to get it for the space that we're actually allocating on chain. Because the way that the Solana account model works is every single account has to have a minimum LAMP port balance, a minimum SOL balance to keep that account alive in the Solana blockchain state. So now that we have that, we can pass in our new account. This is going to be our mint because this is the actual address that we're going to allocate on chain. Next up is going to be our payer, and this is going to be our signer. And let's see what else is here, and program address. So the program address here is the token program that we want to be the owner of this account. Accounts on Solana are owned by other programs. By default, they're owned by the system program. That's sort of a wallet account, if you think of it that way. So like this signer, this is a wallet account, if you will. Because this account that we're creating now is going to be our token mint, it needs to be owned by the token program. So because we are using the original token program, we're going to use token program address that's exported from gill. And now we have allocated our mint on chain. We've created the account. Now we need to tell the token program that this is a mint. It has to have the all the mint functionality inside of it. So the way we do that is another instruction, and we need to initialize our mint. So we're going to call the get initialize mint instruction. And this get initialize mint instruction takes in a whole bunch of parameters. And this is basically how you configure the token you're trying to create. So the first thing is our mint, because we already have that created. And this is actually just going to be an address. So I need mint.address here. And the next is the mint authority. Now, the mint authority is the actual address or signer that's required to sign transactions when you want to mint new tokens. So issuing new tokens to any wallet you want. They have to actually sign this. This is the authorizing key pair in order to actually sign these. After our signer, we can pass in a freeze authority if we want. By default, the freeze authority will be, we'll just set it to our signer.address again. So in the future, if we want to freeze this token or freeze the tokens that are owned by users for some various reasons, you can sign with this address, this freeze authority address. They can sort of freeze those tokens wherever they are. Next, we will say how many decimal places we want our token to have. Depending on whatever your use case for your token is, you might want to change this. 9 decimal places is a pretty common one. So if you think of some of the popular tokens on the network, like Bonk or WIF or anything like that, they typically have 9 decimal places. But if you think of a typical fiat currency, something like USD or euros, they typically have 2 decimal places is how many places that consumers actually see. They actually have technically more than that. And that's it. Now we have initialized our mint. So we could sign and send this transaction right now. And in fact, let's go ahead and do that. So we're going to sign our transaction. We're going to call the sign transaction message with signers function, pass in our transaction. And now we can actually sign and send this transaction to the blockchain. So we can send and confirm. We'll pass in our signed transaction. And in fact, I'll go ahead and log out the Explorer link here too, so we can sort of explore it and see how it actually looks. And then we'll point out what we're missing here for creating our token. You might have already guessed what we're missing. Now, because we're using DevNet for this, I'm going to log out the DevNet Explorer link, and this is going to be a transaction. So I'm going to call the get signature from transaction and pass in our sign transaction. So we'll go ahead and log this out. We can go ahead and minimize this, clear the console. We can run this script again. And this next one is going to fail for a very particular reason, is because I forgot to put in one particular piece of information. So we have created our account, we've initialized it, we've assigned this account to the legacy token program, and we're using this get initialize mint instruction, which within Gill, this is by default using the token 22 program, so the token extension program. So we need to actually use the correct token program address here. So if we pass that in, say this mint is going to be owned by the legacy token program, now we can, we'll clear, we'll attempt this again, and the transaction goes through. We get our Explorer link for DevNet. We can go ahead and open this up, and you can see transaction is actively being confirmed now. You can see here in the URL bar, we're on DevNet, and the transaction goes through. We sent it from Nix6z. That's where we initially signed it from. This is our mint that we actually randomly generated and created. We created the account, we initialized the mint, and everything was successful. Great. But there's no metadata. Let's go ahead and look at this token. We have an unknown token. There's no information stored in here. There's no name, there's no title, description, there's no image, nothing like that. So let's go ahead and now add metadata to this token itself. So back within our code, the way we can add metadata, like I described earlier, is the metadata is added using the token metadata program, because we're using the legacy token program right here. So we can use Metaplex's token metadata program, and we can actually add our metadata. So let's call the the instruction builder for this instruction. So we're going to call get create metadata v3 instruction, because we're going to use the token metadata v3 instructions. So it's really only one that we care about here. And we can just start passing in all of our information that we need here. And you can see there's a whole bunch of information here. We have this metadata object, which is actually an address. We have some of this other information that's actually just passed in, right? So let's go ahead and start filling out all this information, and then I'll explain it as we go. The first thing, this collection details, this can actually be null because we don't really care about it. We're not creating a NFT collection or anything like that. So our token is not part of a collection. It's just a regular token. We have data, which actually has all of our metadata that we can pass in. I'll go ahead and leave this blank for now, and we'll pass in the rest of this information. Is mutable, we're gonna set this to true so we can actually change our metadata after the fact. And in order to change the metadata, you have to have an update authority. So the update authority is similar to the freeze authority or the mint authority. This signer must sign the transaction in order to modify the metadata in the future. And for this example, I'm also just gonna use my signer. Next up, we need our mint itself. So we'll pass that in. And I guess this mint needs to be a address instead of a signer. The metadata. So this metadata attribute here is actually a address. We need to derive an address for our metadata account. So we're gonna create a new variable, call it metadata, and we're gonna call the get token metadata address function. We're gonna pass in our mint, and this is gonna give us a metadata address that is actually gonna store all this information for us on chain. So it's gonna actually create a separate account, not our mint account, because the legacy token program doesn't understand the concept of metadata. So we create another account owned by the token metadata program that will actually contain all this information. And this is actually just gonna be the address of that account. And so we have the PDA that's derived using the correct derivation. And next up will be our mint authority. And because we already have it set up above, we'll pass in our address here, which actually this needs to be a signer. Next up is our payer. This is also going to be our signer. And then we finally have our data. So our data is, again, all the actual metadata information that we want to be stored on chain. So when you look at an Explorer, you look at tokens in your wallet, this is what users are going to see. So what should we put there? There's a bunch of information in here that we actually don't care about right now, because a lot of these are sort of for NFTs and things that are less fungible than a typical token. You have like a whole bunch of supply or whatever. So something like our seller fee basis points, we actually don't care about it because we're not going to have seller fee basis points. Collection also, we don't care about collection because this is not part of a collection. Same thing with creators. There's no creators for this because this isn't an NFT. Same thing with uses. We can also ignore that. And now we can actually pass in the actual information we care about for our token. So the name. I'm going to call this token Super Sweet Token. And next up, we can pass in a symbol, and I'm going to call this SST. And the last thing we need is this URI. So this URI value is an off-chain URI for creating tokens. This is sort of off-chain metadata. Typically, this is a JSON file that you can pass in and actually have additional metadata get displayed. So how you get your image and all these types of things. That's actually how you get this. So for this example, I'm just going to grab a JSON file that is inside of the Solana developers GitHub org, and we'll open this up and show you what this actually looks like. So it has this JSON information in here, pretty standard stuff. We can zoom in some. It has an image URL that we can open if we want. And look, there's a pretty image, yay. And it has just this other information. This is the type of information that will actually get displayed when you mint your token. So now that we have this, we can sign and send this transaction. So let's go ahead and do that. Because now we'll create the transaction with our metadata, and our transaction goes through. We can open this up in the Explorer, switch up my screens here. Transactions being actively confirmed. We have this similar information. We have a different mint that we created because they're just different mints. We were randomly generating them. We have our metadata address. And you can see our transaction here was completely successful. We called 3 different programs. We have metadata program in here, and we can go ahead and open up our mint. Now we have our mint created. We have a title here, super sweet token. And we have similar information. We have 9 decimal places, we can refresh, and we have this token. And that's it. So we've now created our very first token on the Solana network using the token metadata and legacy token programs. So that was a lot of code in order to actually build this transaction, right? Like I got the secret. Gill has these transaction builders, which make it really easy to do all of this stuff that you want to do with like creating tokens. So all of this logic here, I would say probably everything from line 34 all the way down to 80. This is several functions we call and lots of stuff going on here, but I'm gonna show you the quickest and easiest way to actually create tokens on Solana. Are you ready for this? We'll call this TX2, and we're going to use the build, one of the transaction builders, and we're gonna use the build create token transaction. This looks very similar to building a normal transaction. In fact, I'll even copy and paste some of this information here. So we'll grab a fee payer, we'll grab our transaction version, and we can start passing in all of this information that we need in order to create our token. We can pass in our metadata, so I'll just copy and paste this, get this actual metadata in here, and is mutable will be true. We can now pass in our mint, and there we go. We have almost the exact same thing. Now we'll pass in our latest block hash, and there we go. Now we have the exact same transaction that looks basically way simpler, right? Same metadata, same information. We're going to generate new ones. So we can go ahead and remove all of this code here. Get rid of this. We'll rename this to TX2, and we can, remove all these imports if we want. Clean up this code some. And boom. Now this file is way simpler. We can sign and send this again, and it's going to do the exact same thing. We'll switch over to the Explorer. We created a new mint, randomly generated. As this loads, we have super sweet token. We have 9 decimal places, all the exact same information we just did, except way easier. We created the metadata. We have all this information. And the way that under the hood this create token transaction builder works is it just fully constructs the transaction for you, helps you set safe defaults. This will default to the token metadata program using the legacy token program. But if you want to use the token 22 program, token 22 program address, it's that simple. You can just switch the program, and now this transaction will be built actually quite differently, but it does the exact same thing. You create a token with metadata. So how do you actually mint some tokens? Well, check out the next video.